here is the one more topic, that is operators. Operator is a symbol which has fixed meaning in programming. So example 6 plus 4 into 3. So in this example, the 6, 4, 2, these are called as the operands, or we can also call it as the variables, because in every problem it won't be constant, these numbers won't be constant. So these numbers are the variables. It varies from one program to another program, it depends on the user. Whereas this plus and into are called as the operators. So these are constant, we cannot change these symbols. So 6, 4, 2 are the operands, and plus and into are called as the operators. Now we have the three types of operators. The first one is unary operator, second one is binary operator, and third one is ternary operator. So let's see the first one. So in unary operator, this operator will take minimum one operand. So in these operators, we will have only the one operand, nothing but one variable. So that is unary plus. In this we will have we will use only the one operand. And unary minus, and in increment and in decrement. So these are the operators, not the operands. But in this unary operator, we will take only minimum one operand. The next one is a binary operator. In binary operator, it takes minimum two operands. So we will be having the two variables in binary operator. So the examples for the binary operators are arithmetic operators, logical, relational, and the bitwise operators. So on all these four operators, we will use the binary operator because it contains minimum two operands. And third one, that is the ternary operator. So in ternary operator, it takes minimum three operands. So example is the conditional operator. Now in these operators, there are some types. So there are 9 operators in C. So the first one is arithmetic operators, second are relational operators, third logical operators, fourth increment and decrement operators, fifth one assignment operators, sixth one bitwise operators, and seventh is size of operator, eighth is comma operator, and the ninth is conditional operators. So we will discuss all these operators one by one. In this session, we shall see the arithmetic operator. So these operators are used to perform basic arithmetic operators. So in this, we will have the sum of the operators, which are the mathematical operators, or we can also call it as arithmetic operators. So the first one is plus symbol. So this is the meaning of this symbol is addition. So for example, 7 plus 4 is equals to 11. And this minus symbol is for the subtraction, and 9 minus 3 is 6. And the into, this is we call it as asterisk, which we use for the multiplication of two numbers. So the meaning of this is multiplication, and the example is 5 into 7 is equals to 35. So this arithmetic operator comes under the binary operators because we will have the minimum two operands. So in the first example, the operands are 7 and 4, and here 9, 3, and here 5, 7. So to perform the arithmetic operators, we require minimum two operands. So that's why it is come under the binary operator. Then we have the division. This is a forward slash symbol we use for the division, and 9 divided by 4 is equals to 2. So whenever we divide the 9 with 4, we get the quotient as 2. So we use the forward slash mean for the division to get the quotient as the output. And the next one is modulo division. So this is a percentile symbol. We use this modulo division to get the remainder as the output. So 12 divided by 5. So when we divide the 12 with 5, we get the remainder as 2. So we use this percentile symbol, that is a modulo division, to get the remainder as output. We shall see some of the examples here. 9 percentile 4 is equals to 1. 9 modulo division 4 equal to 1. So when we divide the 9 with 4, we get the remainder as 1. When we divide 56 by 9, we get the remainder as 2. when we divide the 32 by 7, we get the remainder as 4. And when we divide 12 with the 14, we get the 12. So here in this case, we are in all the cases, we are taking the dividend as the greater number than the divisor. But in this case, the dividend is less than the divisor. So in this case, the dividend will be the output. We will be getting the dividend as the output. And 18 percentile 5, the output as 3. And 19 percentile 36, in this the case also the divisor is greater than the dividend. So at this case, the dividend will be we will be getting dividend as the output. And 2 percentile 8, 2 modulo division 8. So in this case also the same, because the divisor is greater than the dividend, so we got the dividend as the output, that is 2. So this is the difference between the division and the modular division. And we have the note point, the if numerator value is less than denominator, nothing but the, so whenever we are, if you take these 3 examples, that is if numerator value is less than the denominator, then percentile always returns the numerator value only. So it returns always the dividend, that is the numerator value only. So here also the numerator value is less than the denominator, so this percentile always returns the numerator value. Now the example is, so we have to include the header files as we did in the previous, and every time I will be writing from the main function. So int main, and open the block, clear screen, and printf percentile d. It performs this percentile d for the 12 percentile 14. So whenever whatever the values we give here, that will be executed here. So get ch and return 0. So output we will get it as 12, because here the numerator value is less than the denominator. So this is example for this note pointer. So whenever the numerator value is less than the denominator, then this percentile always returns the numerator value only. So when we perform this operation, we will get the output as 12. And the next 24 percentile 1.2. So that equals to syntax error. So we get the syntax error because the percentile operator is not applicable for the floating point numbers. So we are taking the divisor as the 1.2. So but this percentile operator does not applicable for the floating point numbers. So we get the syntax error or the invalid expression. We have some of the types in arithmetic operators. The first one is integer arithmetic. So given 2 or more inputs are integers, then result will also be as a integer. So when we see the example here, 4 plus 10. So here 4 is an integer and 10 is also integer. Not only 2 inputs, if we give more than 2 inputs, then which are the integers, then the result will also be an integer. When we give 4 and 10, 2 integers as inputs, then output we get it as 14, which is also an integer. And 7 divided by 4, both inputs are the integers and the result is also integer. And 9 divided by 5 is equal to 1. So 9 and 5 are inputs which are integer, and the final result is also an integer. So this is an integer arithmetic. Next, real arithmetic, nothing but the floating point. So given 2 or more inputs are floating points, then result will also be in a floating point number only. So if we see the example here, 1.2 plus 3.4. So 1.2 is a floating point number and 3.4 is also a floating point number. So we are giving the 2 inputs here. Not only 2, we can give more than 2 inputs. So these 2 inputs are the floating point numbers. Then result is also a floating point number. So 1.2 plus 3.4 is 4.6. And second example is 3.4, which is a floating point number, and minus 2.1, which is also a floating point number. So the result 5.3 is also a floating point number. So real arithmetic nothing but whenever the given 2 or more inputs are the floating point numbers, then the result will also be a floating point number. So this is a real arithmetic. Next, mixed mode arithmetic. In this mixed mode arithmetic, we will give the inputs as the combination of the integers as well as the floating point number. So whenever we give the 2 or more inputs are combinations of integer and floating point numbers, then result will be a floating point number. So here we are example, if you see 5 plus 6 plus 1.2. So 5 and 6 are the integers and 1.2 is a floating point number. So the result we will get it as 12.2, which is also a floating point number. And next 9 minus 3 minus 4.6. 9, 3 are the integers and minus 4.6 is a floating point number. So result we got it as 1.4, which is also a floating point number. Next 9 divided by 3.2. So then 9 numerator is the floating point integer and 3.2 denominator is the floating point number. So the result we will get it as 2.2. So this is about the mixed mode arithmetic. In arithmetic operator we have the three types. One is integer arithmetic, next real arithmetic, and the mixed mode arithmetic. Let's see the C program to implement arithmetic operators, which is an important one, and it can be also asked in the exam. So in this program, first we will include the header files. So as include stdio.h and as include conio.h, and it starts from the main function. So in main, open the block int a comma b comma result. So that is, I am declaring three variables a, b and result, which are of the integer data type. I am using the int data type because I have to give only a, b result, a and b inputs as the integer numbers only. So whenever I use the float, then I can have to give the a and b as floating point numbers, and result also will be in the floating point number. So when we use the float data type here, if I don't give a and b as float point numbers, but the result will be in the floating point number only. But here I want to take a and b as the integers, and I want to print the result also in the integer form only. So that's why I'm using the data type as int. Then next, clear screen. So the output of the previous programs will be cleared. So the program starts here. First printf. So please enter two integer numbers. So this printf statement will be displayed in the output screen. So whenever we see this, we have to enter the two integers only. So to read those two integers, we have to give the address to the integers. So scanf %d and close the double quotes, and the first percentile is for the a and second percentile is for the b. So whenever we are giving the two integers, so first value will be taken by the a and the next integer value will be taken by the b. So we have to read those two a and b values, whatever we gave it from the console. So for that we are using the scanf. This scanf we are using to read the values of a and b. So after reading that, now we have to perform all the arithmetic operators, the addition, subtraction, multiplication, division and modulo division. So the first one is addition. At first, result equal to a plus b and ended by the semicolon. So here you can see, after every statement we are closing with the semicolon. So we have to use all these semicolon, then only the program will be executed. So result equal to a plus b. So a plus b, whatever the two integer numbers I gave it from the console, that will be stored in the result. And the operation I am performing is addition. So after performing this, I want to print a statement that addition of percentile d and percentile d is percentile d and the \n and a comma b comma result. So I gave the two numbers from the integer, from the console. Those are of the two integer types. Now the first percentile d takes the value of a, second percentile d is for the value of b, and the third percentile d is for the final result. So for example, from the console, if I give the two numbers as 2 and 3, then this operation will be performed and immediately this printf statement will be executed. So it prints that addition of 2 and 3 is 6. So because first a value I took 2 and b value I took it as 3, and when this operation is performed, 2 plus 3 is 5. So addition of 2 and 3 is 5. So the similarly the next subtraction operator, so result equals to a minus b, and remember that whatever the starting two numbers I gave, with the two numbers only I am performing all these operators. So a value of a and b does not change here. So result equals to a minus b. So then it prints that subtraction of percentile d and percentile d is percentile d and the backslash n. So here we are using the backslash n because to get to print this all the statements in a line wise. So whenever we don't use the backslash n, this subtraction and this statement will be printed soon after completion of this before statement. So to separate it we are using the backslash n. So we use this to get a new line. And the percentile d is for e, second percentile d is for b, and the third percentile d is for result. Now in this result the value will be stored as a minus b. So 2 minus 3, 2 minus 3 nothing but minus 1. So minus 1 will be stored in the result. So we get subtraction of 2 and 3 is minus 1. And the next one is result is equals to a into b. So this is asterisk and ended with the semicolon. So it prints the statement multiplication of percentile d and percentile d is percentile d, and the backslash n. First percentile is for a, second percentile d is for b, and third percentile d is for the result. Now result will be 2 into 3. Inputs I gave it as 2 and 3. So 2 into 3 is equals to 6. So multiplication of 2 and 3 is 6. And the next one is result equal to a by b. So then it prints that printf division of percentile d and percentile d is percentile d. So 2 and 3. So whenever I took 2 divided by 3, then that answer will be stored in the result and it will be printed here. And the next one is result equals to a percentile b. So 2 percentile 3. So whenever I told you that if numerator is less than the denominator, then it prints then modular division prints only the numerator value. So 2 and 3. So modular division of 2 and 3 is 2. So then after get ch and return 0 and close the block here. So this is the performing of the arithmetic operators. I'll take two of the integers from the console, then these all statements will be executed. So first one is addition, subtraction and multiplication, division and the modular division. So I will explain you this output if I take the two numbers. Here is the output. The first statement is please enter two integer numbers. So I am entering 10 and 4 and all the statements will be executed one by one. The addition of 10 and 4. 10 and 4 is 14 and subtraction of 10 and 4 is 6. Multiplication of 10 and 4 is 40 and division of 10 and 4. So when we divide 10 and 4, the quotient we get it as 2. And modular division on 10 and 4 is 2 because whenever we divide the 10 with 4, we get the remainder as 2 because we are using the modular division. So this is the final output for the arithmetic operators. This is a important program.